do you see? What do you see?
Fire.
What color do you see?
Orange.
And?
Green.
Green. What's the green?
Green.
Copper. Remember your flame tests last year?
On the side. I don't see green at all. Well, green's on the top.
It's in the middle.
Oh!
Now it did.
Yeah, still not. No.
Yeah.
Come closer.
Oh, wait, now it's from the side.
Okay. Now, we're red hot, right?
Yeah. How come it hasn't melted yet?
Because older pennies were made of a higher percentage of copper. Now if I
Put it on the table. How did you think all those pennies got melted?
don't breathe the toxic fumes. But by conduction, right? I branded the plastic sheeting on the table.
If we were totally okay with it, would you brand us with a protected OMG?
Are you retarded?
Yes. Right here. Property of Dr. Steve.
Alright, so now I gotta hang on to this guy.
Chicken pad.
So the older pennies are more rare, right? But I can reuse them.
Wait, so can we legit sell that copper?
It's not worth it.
I thought it was the copper we used.
I mean, it's more expensive than it is to actually make the penny. That's why they don't use the copper anymore. And it's expensive enough that people, you've heard about the last several years, there have been all kinds of copper theft. They go to these building sites where they have these spools of copper and
They'll go and try and connect from the wires and they'll get electrocuted. Yeah.
So they're brilliant like that. But yeah, so there you go. Now, not only do different materials have different boiling and melting points, right? Those properties, but they also require different amounts of energy to change their temperature. And to demonstrate that, I am going to, it's okay with you guys, I'm going to stick my hand in this flame.
Nice. Do it! Wait, put some germ gel on your hands. Have you heard that? You put germ gel on your hands, germ gel burns.
That's true. But I'm talking, I mean, I'm not talking just like that.
Jordan.
I'm going to actually stick my hand in there and hold it for, you know, I don't know, 10 seconds.
Don't do that.
Who thinks I'll do it? Or who wants to see me do it?
Yeah.
He's got balls.
Yeah.
I think Jimmy's awesome.
I think that's it.
All right. Here we go.
He's hurt.
Oh, wait. Can I use this?
Sure. Well,
No.
you said no.
I mean, would this make it illegal? Is there anybody okay with this?
That's
Using? I mean, that's okay, right?
I'm kind of.
You won't mind me. Oh, crap.
Gas.
Hey, nobody objects to me using paper towel, right? That wouldn't be cheating.
That'd be stupid.
Actually,
Okay.
Oh, you're gonna get it. That's.
Why are you wrapping up? Oh.
There's a burn square.
really?
Better have a plan to get the paper towel.
Oh wow.
Cheater.
You might as well just put your hand, let him in ice cold water,
We never
and
said
stick
you
your
could
hand
use
in
water.
molten lead. So it's getting hot. It just.
Dr. Steve, we never allow water.
You know what makes them drink? I don't want to see the
What's happening?
It smells so good.
The water's evaporating before the water.
Actually, no, I'm not.
Smells like
I mean, some of it is evaporating, but for the most part, I'm not letting it all evaporate because
The heat's transferring to that, not your hand.
Wait, can we try the germ
Yeah.
gel thing?
what's true about, what about that metal? Why can't I just wrap my hand in metal and stick it in there?
Because
Conducts
metal
heat.
conducts heat.
Yeah, metal conducts heat, and it also is really easy to raise the temperature of metal. It doesn't take very much energy to raise the temperature of metal. Guess what about water?
It's hard to
It takes a lot of energy to raise the temperature of water.
So that's why
That's false. Watch pops boil all the time.
they
Right.
just take a really long time.
So I can sit it there and nothing will happen. Absolutely nothing will happen to this wad of paper towel in the Bunsen or in the Meker burner. Well, except for the part that's drying out and catching on fire. Other than that,
Zero specializes for both.
Well, you can't
actually
burn
we
wet
do.
wood. Well, you can't burn wet wood.
That's why it's so hard to burn wet wood.
Exactly, yes. Now,
Really?
Speak over.
but now I want to apply it to something else.
Giorgio.
We turned off sex.
Hey.
What,
It smells so good. It smells like camping. Let's go take a
hey, what is, who's been to London?
Oh, well, yeah.
Oh, really?
Oh,
Okay.
I stick in America.
America.
What month of the year did you go to London? July. Okay. What was the temperature like?
It was humid, I think. It was just really rainy, so I don't really remember the culture
Okay.
that much. It was just humid.
Were you uncomfortable?
Yes. But it wasn't actually.
But not like Texas hot, right?
No, I'm not uncomfortable now.
Okay. I actually was in London in December. And I did wear a light jacket one day. It's pretty comfortable.
Yeah, it is.
Why?
Because of the Gulf Stream current. It's like hotter than the Gulf.
Okay.
No one's fun.
Let's see, it's high.
God.
On the
God doesn't.
all the Earth is higher than
But it's always kind of rainy.
the top.
Wouldn't that mean it'd be colder?
Oh, it's latitude maybe. Let's look at its latitude. There's England right there. London is right there. Let's follow along its latitude and see where we end up.
Canada and
Yeah.
Russia
Oh my gosh. Prince Edward Island in Canada.
and Russia on the
What's Canada like
Sounds cold.
in December?
Freezing.
Freezing.
polar bears?
Yes.
So if it's at the same latitude as northern, or not northern Canada, but Canada, actually it is northern Canada, right? So pretty good. Why, in December, can I go pretty much without a jacket most of the time, whereas in Canada, not so much?
It's the currents.
Coming from the Gulf.
The currents of the sea.
It's not currents from the Gulf, but it is true that England is surrounded by
Water.
water.
Wait, I thought it snowed.
Oh.
All the water.
Well, yeah, I mean, I'm not saying it's never cold, just compared to Canada. Okay.
What's the reason?
Surrounded by water. And what did we just say about water? It takes a long time to change temperatures, right? It takes a lot of energy to change temperatures. And so that's why England is much more temperate, right? Much less extreme in its weather, in spite of its very northern latitude. Same thing with California. San Francisco. In San Francisco? What's the temperature like in San Francisco?
Really nice.
Yeah, it's nice. Not a lot of extremes in San Francisco. One of the reasons is, sitting there on that west coast, it's got this bank of mountains, right? That kind of isolates it. It's just sitting there hugged up against the sea.
Why is it still like super hot now when it's cold?
What's that?
Why does it get extremely hot?
Well, actually, I mean, temperature-wise, it's the humidity that suffocates you. Yeah, temperature-wise, it's not as bad as West Texas. Now, but wait a minute. Is that always true? Let's come up here to Alaska. Right? I was up here recently too, right?
It's even higher than.
Because the sea is, it's the same but for cold.
Exactly. It doesn't change temperature easily. So once it's already really cold, it's going to stay
Yeah,
cold,
you
right?
can even see that in like the little ice
Yeah,
Yes.
exactly. Yep. All right, so that's one of the cool things about water, right, is that it has a very high, what we call specific heat capacity. And specific heat capacity is a measure of how much energy is required to change a material's temperature. Specific heat capacity. Specific heat capacity is a property of a material, and it is the amount of energy required to change its temperature.
Now, could you apply kind of like the whole force time deal, like a lot of energy in a small amount of time, or a small amount of energy in a long amount of time to do the same result?
Well, yeah, because we do talk about the rate of heat transfer. Right now we're just talking about the bulk of energy, but yes. The symbol for specific heat capacity is little c. And there's a few different units that we want to talk about. We're talking about heat energy. One is what? What energy unit do you already know?
Fahrenheit.
What energy unit do you already know? Joules. Right? And so can joules be used to describe energy, thermal energy? Yes. And so we're mostly going to use C in the units joules per kilogram degrees Celsius. That means joules on top and kilograms and degrees Celsius on the bottom. Why are those the units? Because here's the relationship. The amount of heat required to change a material's temperature is equal to its specific heat capacity. And is that direct or indirect? Direct, right? The larger the specific heat capacity, the more heat's going to be required to change its temperature. Times what else is going to affect it? The mass. Is that going to be direct or indirect? Direct, because the more mass I have, the more energy is going to be required to change its temperature. And the change in temperature. And is that direct or inverse?
Direct.
That is direct as well. If the more I want to change the temperature, the more energy it's going to take. Q is thermal energy. How much heat, how much energy is it going to take to change the temperature? Now do you see where those units came from? Right? Kilograms and degrees Celsius have to be on bottom because they're going to cancel this kilogram and this degree Celsius. And joules has to be on top because that's what energy is going to end up being. The specific heat of water. And I'm going to give these to this. You don't have to memorize. I'm going to give it to you. 4,186 joules per kilogram degrees Celsius. In other words, if I want to raise 1 kilogram of water 1 degree Celsius, it's going to take me 4,186 joules. Now, in the English system, we have another unit for energy that's associated with the specific heat of water. And this you're not going to be responsible for, but it's just fun to know. That's also 1 calorie per gram degrees Celsius. In other words, a calorie is a measure of energy, and it's the amount of energy required to change 1 gram of water 1 degree Celsius. Incidentally, notice what type of C I use to spell calorie with. Lowercase c. I never write with lowercase. That's because there's a difference between a lowercase c and an uppercase c. A big C calorie, like this, A, big C, A-L-O-R-I-E, right? A big C calorie is actually a kilocalorie. It's 1,000 little calories.
So we see on the nutrition box 1 calorie.
Exactly.
That's a lot more.
So when your candy bar says it has 200 calories in it, that's big C calories. What it really means is 200,000 calories. Now, how many of you would eat it if it said it was 200,000 calories?
That's the point.
Well,
Are they really 200,000 or is that just...
it really is. But what's the difference? Does it matter? No, because if you use little c calories, how many calories do you get to eat a day?
200,000.
2 million, right? 2,000 calories, right? Which is 2,000, right? 2 million little c calories. So it all comes out to lunch. All right, we'll pick up there on